All right, good morning, everybody. Let's do this. Lesson 10, the geometric effect of some complex arithmetic. For this part one, what I want us to do is, if you feel like a little shaky on some of the topics we talked about previously, this review is optional for you to kind of get a better feel of what's going on. We're not going to do this page until part two, okay? So this is just part one, and what I did was I created some questions that I thought would help kind of review the topics we've been talking about. So here, let's look at the first part. The learning intention we'll get to into the next section. So here, let z equal negative 4 plus zi, 7i, and w equal 5 plus 4i. Here, calculate these three, okay? And if you're looking at these symbols and you're like, oh boy, what is going on? Well, here, if I have z is equal to negative 4 plus 7i, this z bar, what does it do? It takes the complex conjugate, right? And what would be the complex conjugate of negative 4 plus 7i? It's just negative 4 minus 7i. And that's it, okay? Here, this is, do not think absolute value. No absolute value. Think modulus, okay? And in the next section, we'll talk about what these two mean geometrically. But here, the modulus of z is equal to the square root of a squared plus b squared. Okay? So if I have my z, let's take a look at z over here. This is my a, and this is my b. So I'm just plugging in the a over here and the b over here, and I'm just simply going to have the square root of negative 4 squared plus 7 squared, and that's equal to square root of 16 plus 49, which is equal to the square root of 65. And then here, we can't simplify this anymore, so we leave it just like that, okay? And let's look at this example here, z over w. What are you supposed to do? You're supposed to take this z, put it on top, which is negative 4 plus 7i, and you take this w, which is 5 plus 4i, and you just put it on the bottom. And here, we are dividing complex numbers, okay? And then how do we do this? What was the magical move you're going to do? To divide complex numbers, we will put here, take the complex conjugate of the denominator. Okay? And you're going to take the complex conjugate of this denominator. What is the complex conjugate of 5 plus 4i? It's 5 minus 4i. And you're just going to multiply the top and the bottom by 5 minus 4i. And you're just going to do your math that you're very used to doing. So this is just simply what goes on top. It's this negative 4 plus 7i times 5 minus 4i. You see how these two just go on top and they're binomials. And here this is 5 plus 4i is on the bottom, and this is 5 minus 4i, which is on the bottom. And you'll see, remember, when we're having a complex number, you can't have I in the denominator. And what this will do is it will cancel it out. So what I want you to do is try to solve this on your own. And if you want to see how it's done, let's take a look. This simply is equal to negative 4 times 5 is negative 20. Negative 4 times negative 4i is plus 16i. 7i times 5 is 35i. And then 7i times negative 4i is negative 28. 7 times the negative 4 is negative 28. I times I is I squared. Okay? And then we just do the bottom here. But here, what's nice about this is if I have some a plus bi times some a minus bi, you see here, this is a complex number, and this is the conjugate. This is a complex number, and it's the conjugate. It will always equal just a squared plus b squared. every time. If you FOIL this the same way we FOILed the top, it'll be the same as just taking here, what's my A? It's 5. What's my B? It's 4. And if you just square them, what do we get? We get 25 plus 16, and it equals 41. You will get 41 on the bottom if you do this. If you want, why don't you just FOIL it for yourself and see what happens? But from now on, we have to get used to this rhythm that if I see a complex number times its conjugate, it's just a squared plus b squared. Okay? If you want, I could show it to you some other time. But here, the bottom is 41, and let's simplify the top. It's just negative 20, right? 16i plus 35i will be 51i, and negative 28i squared, right? That's just negative 28 times negative 1, because I squared is equal to negative 1, so this just becomes 28. So I just put a plus 28 here, and this is 41 on the bottom. And then here I'm going to combine negative 20 plus 28, which is 8 plus 51i over 41. And now we do our split. So we just have 8 over 41 plus 51 over 41i. And that's it. And that's how you divide complex numbers. Okay? So, yeah. Let's go on to the next part of the review. These were questions from your quiz. Now here, what does z bar mean geometrically? Well, what I want you to do is try and answer these questions on your own and pause the video. What does z bar mean geometrically? What does the modulus of z mean geometrically? How can you reflect z over the imaginary axis? How can we shift a complex number left and right? And how can we shift a complex number up and down? Okie dokie. I'm going to pause the video, and I want you guys to try and answer these questions on your own. Mean geometrically, so let's say if we have 3 plus 4i. What is the complex conjugate of 3 plus 4i? It'll just be 3 minus 4i. But where is 3 minus 4i on the complex plane? It's 3 and then down to minus 4i. Like minus 4i is here and 3 is here. So this is my point. This is z bar. But what does it do? It reflects it over the x-axis. Okay? That's what z bar does geometrically. What does it mean to take the modulus? So this is the modulus over here. You are taking the distance from a point to the center. So if I have this point here, 3 plus 4i, and I take the modulus of this point, you are calculating the distance from this point to the center. And if you use the same formula we did before with z bar, with the modulus of z of the square root of a squared plus b squared, if you use it for 3 plus 4i, what does this become? This is my a, this is my b. This is what? 9 plus 16. So what's the square root of 9 plus 16? Well, 9 plus 16 is 25. So what's the square root of 25? It's 5. So what this 5 represents is, it's the distance from here to here. So when we had this answer of square root of 65, if I have my point negative 4 minus 7i, which is negative 4 minus 7i, which is right here, the distance from here to here is square root of 65. Okay? That's what that represented. Here, how do I reflect over the imaginary axis? So let's try and look at this example again. Like, this is 3 plus 4i, and this is the conjugate. So the conjugate reflects over the x, but if I take the negative of the conjugate, it reflects it over the y. And we showed this many times in class, okay? For the next part, how can we shift a complex number left and right, and how can we shift a complex number up and down? Let me show you this example over here of how to do it. What I want you to do is take a look at this. Let z equal 4 plus 7i. I'll give you some graphing paper. What I want you to do is plot each one of these. Okay? Calculate this, Like, where is z? Well, z is what? 4 plus 7i, right? So 4 plus 7i is 4, 7i, so boom, right here. And this will be z. And notice what I want you to do is, the game plan is to figure out how to move left and right and how to move up and down. What will do that? Okay, so here, let's look at z minus 4. If I look at z minus 4, it is 4 plus 7i, 4 plus 7i minus 4. And notice we have to combine the like terms, so 4 minus 4 is 0 plus 7i. And notice that this will be where? Where is 0 plus 7i? It's right here. This is z minus 4. But notice when I go minus 4, I am going left 4. Here, when you subtract a real number, you go to the left. So here, when I subtracted 4 from the original z, from z, I just went 4 spaces to my left. Okay? What if I take my original z, right, and I do minus 2i? How does it go? Here, 4 plus 7i minus 2i, that becomes 4. You combine the 7i and the minus 2i, this is 5i. Now, where is this point on the plane? It's 4, and this is 5, right? z 1, 2, 3, 4, 5, and this is the point here. This is z minus 2i. And what did this do? It shifted this point 2 units down. So when we say, how can we shift a complex number up and down, you want to subtract an imaginary number to go down. You see here, if I do z minus 2, it goes left 2. But if I do z minus 2i, it goes down 2. What if I do z plus 2i? It goes up 2. And then let's say if I do z plus 2, it goes right 2. Okay? And then what I want you to do is try and figure out the rest of them. And for this one, for letter E, once you get to it, how does z change? What will happen is you go left 6, down 2. And that is the geometric transformation of what's happening within the complex plane. Okay, I hope this review helped. I will see you.